And welcome back. This lesson is focused on the addition rule in probability. We will get to that after we're done with the warm-up. So go ahead and pause the video and answer these questions to the best of your ability, and then come back and listen to the answers and compare. For this warm-up, it says a student is selected at random from an AP class. Let the event that the student earned an A in the class be A, and the event that the student earned a 5 on the AP exam be F. Okay, and you can see that we have a table that represents these different values. Number one, it says draw a Venn diagram that represents the data. So let me first start off by drawing a Venn diagram. And remember, when we draw a Venn diagram in math, we want to have these lines that extend down because those represent certain values. And I'm going to go ahead and label F and A. Now that means that this circle represents the students that got a 5, and this circle represents the students that got an A. So if you swap those, if you put A here and F here, your answers are going to switch everywhere as well. All right, so we just got to fill out the chart here. Where does the 19 go? Well, the 19 is the group of people that earned an A and earned a 5. So that would be the football shape. That's the inside there. Okay, that's the A and 5. Notice and is one piece. This is the group of people that did not earn a 5 but earned an A. So what is the piece that did not earn a 5? So that means outside of this circle, and earn an A. So that would be here. That'd be the 4. This is the group of people that did not earn an A but got a 5. So that would be here. So that's 13. And then this is the group of people that did not earn an A or a 5, so that would be a 24 out here. To fill out the rest of this Venn diagram, remember we need to add these two numbers to get the totals there. That'd be 32. And then 19 and 4 would give me 23 down at the bottom here. And then the total for the entire Venn diagram would be the sum of these 4 values inside. Again, we don't want to add these 2 values here because we have an overlap, and we're going to talk more about that today. So when I add the 13, the 19, the 4, and the 24, I end up with 46. Now, question 2 says, what does P of A intersect not F mean? Well, that is the probability that a student earned an A and did not get a 5. So that is the answer to number 2. The probability that the student got an A and did not get a 5, or did not get a 5, you could say. Number 3 says find that probability. So remember, when we're talking about an intersection, we're talking about one piece of the puzzle. There's 4 pieces. What is the piece of this puzzle that has A and not a 5? Well, that would be that shaded region right there. And so our probability would be 4 over 46, and then reduced as 2 over 23, and then whatever percentage that is. Let's go ahead and get into today's lesson. The title is Union and the Addition Rule. So you're going to take notes on this, remember, just like you would in class. The objective says I can apply the addition rule to determine the probability that one event or another event will take place. So we're actually going to come up with a rule, an equation, that helps us figure out a certain kind of probability and understand the relationship between some probabilities. Now, if you understand the table and the Venn diagram really well, this rule doesn't really help in the basic cases. It only helps when we're doing more advanced probabilities. But it is an introduction to how it works, and I want you to see it. So with that said, let's go ahead and take a look at an example here. Here's a Venn diagram. We've got A, B, and then the not and the intersection and all that. Okay. So if I was to fill out a table based on this Venn diagram, so we're going backwards from the warm-up. In the warm-up, we started with the table, and I said draw a Venn diagram. Well, here, let's take a Venn diagram and translate it to a table. I think this is really beneficial. Well, what part is event B and event A? What part is event B and event A? Well, that'd be 23 there. Notice one piece of the puzzle correlates to one piece of the table. What part is event A and not B? Well, that would be the 29. What part is not A and is B? That'd be the 34. And what part is event not A and event not B? That would be the 14 outside. Now, what I want to note here, I didn't put the lines here, but if you notice, if I put the lines down here, the 29 plus the 23 is 52. And then the 23 plus the 34 is 57, and then we can figure out the totals here. But if we could see those same numbers if we figure out the totals of the table. 23 plus 29 is 52. That is the total of event A. So 52 is the total of event A. It would be under the line here, and it would be over here. The total for event B would be 57, because we're going to add the 53 and the 34, but we also see that here, the 23 and the 34 add up to 57. And then our total, let's see here, we got 52, because again, we added that to the bottom of the Venn diagram. Event not A is 48. We wouldn't necessarily write that in the Venn diagram anywhere. And then same thing here, we wouldn't write down not B in this Venn diagram as well. And then when we add up the totals, either way, you should get 100. Now here, if we add up the four values here, we should get 100 on the outside as well. So you can see the correlation between the table and the Venn diagram. Every number is represented in either case. Now with that said, let's answer this question. What is the probability of A? Well, in this case, it's pretty simple because our overall number is 100, so we don't have to worry about converting into percentage. It would already be a percentage. But what part is A? Is this A? Yes. Is this A? Yes. Is this A? No. Is this A? No. So A is a total of 29 plus 23, which is 52. And again, we saw that here. A is here. So many students make the mistake that they think this is A. We're not saying just A. We're saying all of A. So don't forget to include the football. So 52% for A. What is the probability of B? Well, that would be the total of B. So that'd be 23 plus 34. We already did the work. That's 57%. What is the probability of A intersect B? A and B. Again, when you see the word and, you're thinking one piece. What piece is both A and B? Well, that'd be the 23%. Now, that's all fine. We've been doing that for a couple days now. But now let's try and figure out some relationships here. Okay, so here's the same exact numbers. Let's take a look at question number 2. What is the probability of A union B? Remember when we talked about the union, we're talking about three things. So what is the parts that are what are the parts that are A or B? Well, is this A or B? Yeah, it's A. Is this A or B? Yeah, it's both. Is this A or B? Yeah, it's B. Is this A or B? No, it's neither. So probability of A union B would be the 29 plus the 23 plus the 24. So you can see it's everything inside those regions. And as a result, you can see that how many pieces did I shade in? I shaded in 3. Well, if we look over at the table and shaded in the same numbers here, we would see that we would be shading in event B. We'd be shading in the part that's not A and B, and we'd be shading in the part that is A but not B. So we'd be shading in those three things as well. So you can see the same numbers, 29, 23, 34, 29, 23, 34. Again, 3 pieces of the puzzle. So when I add those up, I end up with 29 plus 23 plus 34 is 86, and so we get 86%. Now, here's a question for you. Why couldn't we just add A and B for the event space? So for number 2, why couldn't I just say A plus B? Why couldn't I just say 52 plus 57? Well, we've kind of already answered that a little bit in the past. But notice if I add 52 plus 57, I get 109. There's a couple of problems with that. Number 1, that wasn't the answer, so obviously we can't do that. But why? Well, the first thing is 52 plus 57 is over 100%. So that's impossible to have a probability that's higher than 100%. But the real reason, the question that I'm angling at here, is the reason I can't add the 52 and the 57, or why I can't add A plus B, is because when I do that, I'm adding up this middle piece twice. If you were to break up the 52, really what you're saying is you're saying 29 plus 23. And if you were to break up the 57, you'd be saying 23 plus 34. So if I rewrote this 52 plus 57, that's kind of like saying, what is 29 plus 23, right? That's my 52, and then plus 23 plus 34. That is my 57 here, right? That's my 57. So what ended up happening? Well, I ended up adding the 29 like I was supposed to, and the 34 like I was supposed to, but notice I added this 23 two times. I don't want to add the 23 two times. So what's the problem with just adding A and B together to get your OR statement? You are adding the intersection of those two things two times, and we don't want to do that. So that's the answer there. But how could we get around that? What if I did want to add A and B? What would I have to do? What would I have to do to figure out A union B? Well, like I said before, we'd be adding the 23 times, two times. We'd be adding the intersection twice, and we don't want to do that. What I could do then, what kind of equation could I come up with that relates all of these three things to the union, Well, and that's the question here. What is the probability of A union B without going through the motions of adding the 29 plus 23 plus 34? Just what's another way of getting that number? Well, we could take the 52 and the 57 and add those together, and we know, like I said before, we would be adding the 23 two times. We don't want to add it two times, we only want to add it once. So if I subtract one of those intersections, I'll get the same answer. 52 plus 57 is 109, minus 23 is in fact 86%. So we end up with the same thing. So how do you find a union? Well, a union could be found by adding the three inside pieces, right? Or it could be found by adding the totals of the two pieces and subtracting the intersection. With that said, that's the addition rule. Go ahead and write that down. The probability of A union B is equal to the probability of A plus the probability of B, but we have a problem with that because we're adding something twice here. We're adding an overlap here twice. So we want to subtract one of those. So we're going to subtract the probability of A intersect B. Okay, that is the addition rule. Now let's go ahead and take a look at a practice problem with this. Of the houses on Ridge Street, 37% have air conditioning, 52% have a security system, and 24% have both central air and a security system. C represents the event that a house has central air, and S represents the event that the house has security system. Determine the following things. 4 questions. Go ahead and pause this video and see what you come up with for each of these things. If you have to, draw a Venn diagram or a table to fill it out, and if that helps you answer these questions. For number 5, what is the probability of C? In other words, what's the probability of having air conditioning? Well, it gave us that. That was 37%. So that was right here. I don't need a Venn diagram to see that. What's the probability of S? Or in other words, what's the probability of having a security system? It gave that to us here, so 52%. What's the probability of C intersect S? In other words, what's the probability that a house has air conditioning and a security system? Well, right here, this means they have both, so that'd be 24%. And now what's the probability of C union S? Or what's the probability of a house having air conditioning or a security system? You notice that information was not given in the prompt. So in order to answer this, you could do one of two things. You could either draw out a Venn diagram and fill these values into the Venn diagram and then figure out the missing pieces, or you can use the addition rule here. We're going to do it both ways so we can see it. But if I want the union, that's the same as taking, let's see here, that's the same as taking one probability plus another probability and subtracting the intersection of those probabilities. So in this case, it would be P of C plus P of S minus P of the intersection of C and S. And since we have all those values, we could just plug them in. So we get 37 plus 52 minus 24, which is 65%. Now, we want to draw a Venn diagram because we want to make sure that this makes sense in our brains. So if we were to fill out this Venn diagram, we got C and S here. Where does the 37% go? My guess is, and I have no way of knowing this other than teaching this for multiple years, my guess is a lot of you put the 37% right here. And that is not true at all. The 37% is the total number of air conditioning. Well, that total goes down here. Ask yourself this, is this the only piece that has air conditioning? No, this piece has air conditioning as well. So you have to include both of these when we're talking about the 37%. That's why we put it down at the bottom there. That's 37. Where does the 52 go? Well, that's the total amount of security systems, so that goes at the bottom. Where does the intersection go? Well, the intersection goes where they overlap. Remember, intersection is one piece. So what one piece has both air conditioning, and security system? That would be in the middle there, so that's 24. Now, how can I figure out the rest of this Venn diagram? Well, what I notice is that the 37 is the total of C, and this part is part of C. So how do I figure out the rest of the air conditioners? Well, I would just subtract those. 37 minus 24 is 13. And I would do the same thing on this side. The total security system is 52, so this is just subtracting the 52 minus the 24, which is 28. And then because we know that this is a total of 100% out here, well, if I add these three things up, I don't get 100%. If I add those up, what do I get? I get 52, 62, 65%. So the leftovers would be 35% because all four of the numbers inside the Venn diagram have to add up to 100%. So we can check our union. What's another way of finding C union S? Well, C union S is three pieces of the Venn diagram. So this piece, and this piece. 13 plus 24 is 37, plus 28 is 65. So you can verify it that way as well. Let's go ahead and take a look at one last problem here for today. The National Camera Museum has a collection of 1,342 different cameras. They have 577 digital cameras and 684 single lens reflex cameras. Of these, there are 255 cameras that are both digital and SLR. So I want you to pause the video and answer these questions on your own to see if you know what you're doing, and then come back and check your answers. For number 9, it says draw a Venn diagram that represents the information. Okay, well, here's the Venn diagram. What are the two things we're comparing? We're comparing digital cameras and SLR. So I'll put a D and an S that represents those two things. What is the 1342? Well, that is the total amount. Oops, going in different places here. Let me take a step back. The 1342 is the total amount of cameras, so I would put that outside, the total amount. The 577 is the digital cameras. Again, this is the total amount of digital cameras, not just this part of the digital cameras. It's including the entire circle, so we want to put that down here. Hopefully you got that. There are 684 single lens reflex cameras, so that's the total here. So those are those two values here. And it says that there are 255 cameras that are both digital and SLR, so that would be the intersection of those, so that'd be 255 there. And then I can figure out the rest of it by subtracting the 255 from the 577 to give me the only digital. And then I can subtract the 255 from the 684 to give me the only SLR. And then from there, because I know the total is 1342, I can add these three things up and then subtract that from 1342 to get the leftovers. Now, in part A of number 10, if a camera is selected at random, what's the probability that it is either a digital or an SLR? So we see the word or, so we say digital or SLR. Remember, we have two ways of doing this. To find an or, remember that's three things. So we could say digital, yes, digital, no, but it is SLR. So, and is this digital? No. Is it SLR? No. So I don't want to include that. So I'm going to add these three things up, 322 plus 255 plus 529 over the entire 1342. But remember, the other option to find an OR is to add the totals, the 577 plus the 684, and then subtract the intersection so we don't add it twice. So ultimately you end up with 75.75 or 75% if you did all that work. For part B, it says the probability that the camera is digital but not SLR. Is this digital? Yes. Is it SLR? No, and that's what we want. Is this digital? Yes. Is it SLR? Yes, so I don't want to include that. Is this digital? No, so I don't want to include that. Is this digital? No, so I don't want to include that. So it would be 322 out of 1342. And so then we'd end up with 24% or 0.24. C, it says, what's the probability that a camera is SLR but not digital? So it's kind of the opposite, the probability that it's S and not D. And so that would be the 429 out of the 1342, which works out to 32%. D, it says neither digital nor an SLR. So that is the part that is nothing. So we would write that as P of not D, intersect not S, and that is this part here, 336 out of 1342, which is 25%. And then what is the probability that the camera is not digital? Well, that's easy enough to write, not digital. But what parts are not digital? Is this digital? Yes, so that means I don't want to include it. Is this digital? Yes. Is this digital? No. Is this digital? No. So we're going to add these two values up, the 429 plus 336 here, and put that over 1342, which works out to 57%. Again, if you have any questions on this, please make sure you're asking me during office hours or emailing me if you need to. But I hope that you understand these concepts. Go ahead and do the practice problems below, and I'll talk to you later.